Alrighty, let's do the last notes for this unit. Today we're going to be talking about probability. Okay, so the probability, there we go, of an event is a measure of the likelihood that the event will occur. All right, so a geometric probability, basically all this means is that we're throwing in some shapes, right? Probability is a ratio that involves a geometric measure such as length or area. All right, so to calculate probability, what you're going to do is that you're going to find a ratio of what you want out of the total that you have. All right, and that is going to give you a decimal, give you the ratio as a decimal. But then when we talk about the chances of probability, we always convert that into a percentage. So when you get what you want divided by the total that you have, then you're also going to turn that into a percent. So you're going to take that and you're going to multiply it by 100, and that's going to give you the percent of probability. Okay, so again, it's very important, and we're going to do some examples that it's what you want out of the total that you have. So for these examples, find the probability that a point chosen at random will land in the shaded region. So the shaded region is basically the area of what we want. So the area of what we want. So I kind of like to do a little like, hey, let's write out how we're going to approach this problem. So we're going to find the area of the rectangle, and we are going to subtract out the area of the triangle. And basically when we do that, this is going to equal what we want. Okay, now the part about the total comes from is the area of the largest shape that you are given. So for example, in this one, like the total would be the area of the rectangle. All right, and this other one, the total would be the area of the pentagon. All right, so you'll see kind of how that changes. So the area of the rectangle, so the area of the rectangle, right, is length times width, base times height, whatever you want to say. So that's 36 centimeters squared. And then my area of my triangle, so area of the triangle is the base times the height. Well, this height here, right? Height is always perpendicular to the base. This right here is 4 centimeters, so this is going to be 4 centimeters. So base times height, all of that divided by 2. So 36 divided by 2, we get 18 centimeters. So to get what we want, we are going to take the area of the rectangle and subtract out the area of the triangle, and we get 18. So we have 18 out of the total, which is 36. So if we divide that, we get 0.5. We times that by 100, and the chances here happen to be 50%. Okay, that just happens to be a lucky 50%. All right, so that is a 50% chance. So pretend like you're throwing darts. You have a 50% chance of landing in the shaded region. That's kind of how you can think about a point chosen at random. Or if you close your eyes and you go, okay, and you put your finger down in a spot, it's going to be a 50% chance that you land in the shaded region. All right, so this second one, we're going to do the area of the pentagon, and we're going to subtract out the area of the circle, okay? Area of the pentagon, it is the apothem times the perimeter, all divided by 2. All right, so we are given the apothem, because remember the apothem goes from the center perpendicular to the side. So we are given the apothem. then we have to find the perimeter. So if we were in class, we would be teaching you how to find the measure of this side using trigonometry. But since we're just simplifying the curriculum because of the online learning, I'm going to go ahead and add this, and I'm going to tell you that this side, and I have used my calculator, and I'm going to round to, I guess, to the 100th. And so I'm going to tell you that this side is 10.17. And I actually found that by using trig. Okay, so if we want the perimeter, right, we're going to have to take that 10.17 and we're going to have to times it by 5 sides. And so that is actually going to give me, it is 50.85. Okay, so again, go ahead and add this 10.17 as a side length of the pentagon. All right, so we have 50.85 times 7. And we're going to divide that by 2, and we're going to get an area of 177.98. Okay, let's just say we're rounding to 100th. All right. Now that's the area of our pentagon. Now we want to find the area of the circle. So that is pi r squared. And this apothem happens to also be the radius of the circle. So this is 49 pi, which is approximately 153.94. Okay, so to get what we want, we're going to have to subtract that circle out of that pentagon there. So we're going to have to do 177.98 minus 153.94. Okay, minus 177.98 is 24.04. So this is actually what we want. Okay, so when you do your subtracting, that's usually what you want, right? We want this shaded part, so it's not a lot. So this is the only shaded area, okay? Out of the total, again, the total is the outside, the larger. So the total is our pentagon, which is 177.98. So we're going to do 24.04 divided by 177.98. And that gives us 0.135. We're going to times that by 100. So this is a 13.5% chance that when you throw a dart, you are going to land in that shaded region. And right, this should make sense. There's not a lot of shaded areas, so this number should be really small. All right, number 3. So we have basically a square. Okay, and we are taking out, a half circle and a half circle is one whole circle. So we're going to do the area of the square and we're going to subtract out the area of the circle. Okay, again, pay attention to how much circle. This is, okay, this is one whole circle. All right, so area of the square is going to give me what, 100? And area of the circle, so pi, well, if this whole thing is 10, be careful then, your radius is going to be 5. So pi r squared, that is 25 pi. Okay, when we are dealing with probability, we don't leave things in exact form. Okay, so 25 pi is approximately 78.54. All right, now we're going to subtract those, right? We need 100 minus 78.54 to get what we want. Minus, take that out, so that is 21.46. So this is what we want, divided by the total, the biggest shape that we have, okay? And that's actually, since we're dividing it by 100, then timesing it by 100, we are actually going to have a 21.46%, or if you say round to the nearest 10th, ladies and gentlemen, who don't like to round to the nearest 10th, right? I'm not going back and changing any more quizzes. If you don't round to what you're supposed to round to, it's wrong. I'm tired of, y'all not paying attention. So pay attention, okay? If it said round to the nearest 10th, we would take it to 21.5. it said round to the nearest hundredth, we would take it to 21.46. So please pay attention to the directions. All right, 4 is a little bit different because the shaded region is actually smaller than the total, okay? So this one we're actually going to take, okay, the area of this is 24, the area of this is 27. So I want the shaded region. So if I add those together, I actually get 51. So this is what I want out of the total, this big rectangle. If I want the area 10 times 45 is 450, okay? So again, what you want is the shaded region. Most of the time, you'll see that you have to subtract to get what you want. This one, we're just going to add. So now we're going to divide 51 by 450, and this is what we get. Times it by 100. Hey, let's go to the 10th. So 11.3% chance that you're going to land in the shaded region. Okay, now don't think that that's wrong. I mean, a lot of times these figures are not drawn to scale, so that is correct. We divided what we wanted by the total that we have. One more. All right, so this one again should be pretty easy. We're going to take the area here, which is 9 of the larger one, right? This is 9 centimeters squared. This is 4 centimeters squared. So if I do 9 minus 4, I get 5. Well, this is what I want. Out of the total, the big one, the outside, is 9. So 5 divided by 9 gives me 0.5556. Times that by 100. Hey, let's round to the nearest 10th. Oh, who would think of such a thing? So 55 rounded to the nearest 10th, 6. Okay. Pay attention to what you should be rounding to at all times. So probability, so you're throwing a dart, that's how much of a chance you get to land in the shaded region. This has been fun. Enjoy your day.